Hello everybody, Mark here with Midgard Mercantile once again for another rock, gem, and mineral and fossil live stream. We got all sorts of stuff here to show you guys. Just a little rundown on how we do this. Basically, we have all sorts of stuff from around the world. Everything has a price. All you gotta do is just say, I want that thing in the comments section, and we'll get the order taken care of for you. So, yeah, let's get this ball rolling. So we have some pretty assortments here of palm stones, and our business, we sell all sorts of things like rocks, gems, and minerals. We sell these beautiful palm stones, which are great for like meditation work, or just putting on an altar, putting in a pond. We've had some people come to us for tumbled stones and palm stones for like aquariums and that kind of thing. But these are really pretty. These are pink quartz palm stones. These are $7 each. And, the name, palm stones, they fit perfectly in your palm. So that's basically, why they're called that. The pink quartz here, most of our pink quartz either comes from like our local area in Southern California. So either we mined it, or it comes from all over the world. It could come from Brazil, could come from Mexico, could come from the United States, Madagascar, Morocco, all sorts of places. So we have a lot of sources, but most of our materials, like this stuff that's pretty common, usually comes from our local area. But yeah, these are $7 each. Very, very pretty. A nice kind of pale pink color. Pink quartz is usually good for like healing energy, calming. It's a very healing stone. Next, we're going to look at some more palm stones. These are kind of a newer find for us, since it's more of a rare material. This is bumblebee jasper, and I'm going to show these one at a time. Now, as you can see, they're pretty unique. Now, bumblebee jasper that's what its colloquial name is, but it's actually not a jasper. So jaspers are silicate minerals, meaning that they have silica in them. So SiO2, silica, silicon and oxygen, and this does not have that. This does not have silica in it. This actually has calcium carbonate, so it's actually a calcite. So, but because of the way it looks a lot like a jasper. Jasper commonly has those ripples or waves or wavy layers, and that's because jasper usually forms in muds or sediments, kind of like volcanic ash, for example. This also formed in volcanic ash, but it formed in very saturated volcanic material, so it was by water, lots of water, and wherever you have water evaporating, you'll have calcium carbonate form, which is an evaporate mineral. But just the ash and the soil and the minerals inside of the soil and the ash yielded this gorgeous color. Bumblebee jasper also has some sulfur and some iron and some other things in it that also give it some of that deep, rich color. And bumblebee jasper, the name, right? It looks just like a bumblebee, just bumblebee yellow, really bright and beautiful. Our palm stones for these are $18 each. So the price, you can definitely tell it's a bit on the rare side. Definitely an uncommon mineral, but it's gorgeous. Yeah, the colors are just phenomenal. Now we have all sorts of these too. I mean, each one's a little bit different. Some have more like vibrant yellows, some have more gray with like a little ribbon of yellow. So it really depends on what stone kind of talks to you. Hey, stones talk to me, man. I see a rock on the ground and it's like, pick me up, pick me up. But yeah, these are pretty, very, very gorgeous. And because it's calcite, basically you can shape it very easily. It is a very soft material. These palm stones, you may even notice they're not as smooth as the pink quartz palm stones. And that's because these actually aren't tumbled. These are polished by hand. it's such a soft material that if you put it in a top, like some sort of rock tumbler, it would just eat up the material. It would just go away. So these take lots of delicate kind of, manufacturing work. You have to, polish each one by hand. So there is some size variation, very minimal though. Yeah, this one's gorgeous. Look how bright that is. Oh yeah. Now, bright colors like this, usually if you see a really bright color, whether it's green or blue or yellow, for example, or red, usually that means that the material that you're holding is high in concentration of something. Any dull colors would just kind of indicate, okay, well, it's not a very rich deposit of whatever is causing the color. So you can tell that these are very mineral rich, very mineral rich. I think most people would concur. Yellow is a very happy color. Bumblebee jasper, metaphysically speaking, a lot of people will use it as kind of like a happy stone, positive vibes, that kind of thing. All right, I'm gonna show one more. This one is pretty cool. Yes, lots of sun energy, for sure. So that wraps it up for our Bumblebee Jasper palm stones. I'm going to kind of jump around a little bit. There's another cool kind of like pink mineral, kind of like pink quartz. We got some kunzite. Now kunzite, we've shown these specimens probably every other stream that we've done. Kunzite is a fairly rare silicate mineral. And it's high in lithium and aluminum, which gives it its classic pink color. I'm going to show a couple here. Now, these are fairly expensive, but they're absolutely gorgeous. They're just very rare. All of our specimens come from Afghanistan. And kunzite is very similar to the mineral tourmaline. You may notice some similarities, just the structure of the crystal. It's very rod-like, channels lots of light. And, for this kind of specimen, this is like, most people are probably used to seeing black tourmaline, or maybe watermelon tourmaline. Tourmaline that's translucent and gemmy they're gemstones. Those are things that you'd probably see cut and faceted in a stone, some sort of stone setting or something like that. Kunzite is a gemstone. It's very high quality. All of our pieces here are AAA, meaning that they don't have a lot of fractures. They're actually pretty good for gem cutting. This specimen here is $125. It's our most expensive one in our flat here. And so this one, as you can see, there's a light kind of play here. So wherever the stone is more opaque, that's where the light kind of gets trapped and more like reflected back at our eyes. And you can see here this kind of pinkish hue. That's lithium, high amounts of lithium. Lithium is pretty pink in nature. So whenever you see it in a stone, it's going to color the stone. And basically, because of the stone's shape, because of the crystal shape, wherever you have this translucent section here of the crystal, it channels the light. So the light will come in and reflect off of any highly reflective surface. And that light will reflect back at our eyes, and we'll see pink or blue or whatever. In this case, kunzite, we're going to see pink. Now, because of those channels, that channeling, those rods are going to channel that light. If we turn the stone, we can see a little bit of a color change. So it's clear, more clear on one angle, and then it's more pink from another angle. Likewise, if we turn it this way, we see more pink, right? So, which is why kunzite is such a popular stone for gem cutting and jewelry. It's because of this light channeling ability on the molecular level. It's very eye-catching. People love this stuff. So again, that piece there, 125, and I'm just going to kind of go down the list because we have some pretty cheap ones as well. So we're starting off with the most expensive. This piece here, another piece of AAA quality kunzite from Afghanistan. As you can see, very, very pretty. And just the clarity in that, you know, because we have a white background here, it's kind of hard to see the true brilliance of the stone. It kind of blends in. But this is absolutely gorgeous. Just look at that. See if I can get a really good close-up here. There we go. So you see those striations there, those parallel lines. So basically that's the stone crystal habit. We call that faceting, natural faceting. And so basically that's the direction that the crystal grows. That's its normal growth habit, its habitual growth. So when you see that though, each little line, that is one crystalline rod going up through the whole entire stone. And so each one of those rods, there's probably, you know, hundreds of thousands in here. Each rod is going to be channeling light separately from one another. So each one's channeling the same amount of light through the stone, which makes it very, very bright. Whenever you see this, you may notice these really harsh reflections in the stone that are like black. If I turn this like right there, that just shows you how reflective this stone is and how well it channels the light. It's basically like a kind of similar to fiber optic cable in a way. So this piece here, this is a pretty long piece. This is about $100. It doesn't have a lot of color. You can kind of see a little bit of pink in there. Some of these, the cheaper ones, are going to usually have less color and be a little bit smaller. But what makes this stone, this specimen, a little bit different is that the clarity of the crystal is really high. So notice if you look in there, there's not a lot of fracturing. You can kind of see right through the stone without any issues. That is very, very sought after. If you're a gem cutter, if you're looking for stones to cut and facet, you're looking for that. Fractures, it's going to make the stone explode when you're working on it. You don't want that. But if there's no fractures, you can work on that all day long. Alrighty. Next, we're going to look at probably the next most expensive one here. I think that would probably be this one. So this is $110. There's a little more color in this guy, and we definitely have a little more brilliance here with the stone. Take a look at that. We have basically the end of a kunzite specimen here. We have this beautiful faceting, and it's a nice kind of light pink hue. Very, very light, very, very subtle. And I mean, this is just a massive piece of kunzite. Now, most gemstones, just in general, they're going to be priced per gram. And so, you know, usually that's just how it goes. And they have pretty standardized pricing. So just because of the rarity of high quality gems, it just makes more sense to price them that way. Kind of avoids inflation and that kind of thing. So this piece here, again, $110. A little less color, a little more than the last specimen for sure. Next, we're going to look at a much brighter specimen. This one's really pretty. This is another very high quality specimen of kunzite, $69, quite a drop. You'll notice a difference in size as well. So notice that, clear on this side, we see that color right in there. See that color right on the bottom of the stone? Now if we turn it, look at that. That's pretty brilliant. And the clarity of the crystal too. I mean, if we get a close-up here, absolutely gorgeous. Now, one day, once the world kind of settles down, I would absolutely love to go to Africa, to go to the Middle East, and just rock hound. You know, whenever we go to any of these big rock shows around the world, it's like, you know, whenever we buy from our lovely friends from all around the world, our mine owners, they're always like, oh, come out and visit us, and, you know, you can mine at our mine. And we're like, yeah, that would be awesome. But you live like halfway across the world. But I would love to do that. That's, you know, the rock hounding, like, mining community is such a tight-knit community of people. So very sweet people, most of the time. But yeah, imagine finding this in the mountains somewhere. I mean, these are pegmatitic minerals, meaning that they form in granite, very hard igneous rock. So in the mountains, it takes a lot of heat and pressure to create something like this. All right, here's another one. This is a $63 piece of kunzite. Another pink beauty. Look at that. Now, you may notice, too, that the opaque nature of the stone, wherever the quality lessens, that's where the color is concentrated. And it's not because there's more lithium in that part of the stone. There's lithium throughout the stone. But wherever that opaque area, it's great at reflecting light. So you're going to see more pink in these kinds of stones. You can even tell. Yes, shout out to Khalid and his brother for sure. Yeah, most of our Moroccan fossil specimens come from them. Yeah, I think one of these days we're going to have to, on one of our streams, show some of our... so we have these beautiful plates and dishes that are made out of fossiliferous limestone. Basically, it's limestone with a bunch of like squid and ammonite fossils inside of them, and they've been carved into plates, stone plates. I would love to have a set like that and just eat off of them. But we have a ton of them. We have a ton of these, and they're really cool. Yeah, this piece here is gorgeous. So I think I'm gonna show maybe let's do maybe 2 more, because the rest are kind of like same quality, but I want to kind of move on with the specimens here. So this piece is really nice. This is a very gemmy piece. We have some rainbows in this one too. This is a $35 piece of kunzite. There's quite a bit of fracturing. It's still AAA grade, but there's quite a bit of fracturing in it. So you can even see, though, that AAA quality, right? Basically, you can see right through the stone. And see that little rainbow in there? That is gorgeous. Now, remember, a lot of people think, oh, the rainbows are so cool. And yeah, they are. They reflect light and they, refract it, and they split the light up, and you can see a gorgeous spectrum of color. And as a gem cutter, you don't want microcrystalline fractures like that. That wouldn't be good. And it's, I don't know, each stone's different. I don't like fractures. They make me very anxious, because whenever I'm out mining and I see this gorgeous specimen, if I see a piece that's fractured, it probably means that I hit it. I hit it with a hammer accidentally and it shattered on me, or that's something you don't want to see as a rock hound. It's the saddest moment of your life. Something just working. Imagine you go out in the middle of nowhere, hike up a mountain, right? And you find this gorgeous crystal in the ground, and you spend all day trying to very carefully excavate it out of the rock. And just when you're about to excavate it out, your hammer slips and boom, break the piece. That is the worst feeling in the world. So, but as you can tell, it's a bit of a broken piece, so it's like but it's a nice piece. You have it's really pretty. Just makes me nervous. Now, whenever I'm looking at some of these, I love seeing this crystal habit. As a geologist, it's nice to see that feature there. It's really educational. You can use this as definitely a very good teaching tool. And so, I've never used kunzite as a educational tool. That would be an interesting idea. But black tourmaline, any kind of tourmaline for that matter, would be a great teaching tool to show crystal habit, especially in rods like this. Again, this piece here is $35. Another gorgeous piece with some cool little rainbows in it. Our last piece of kunzite here. This is my favorite piece, and if nobody buys it, by the end of the year, I'm going to just buy it myself. It is very pretty, and it's only $55. which, you know, out of all these specimens here are pretty expensive, but this piece is like beyond gorgeous. I love this piece. Take a look at this. Now, what's really cool about this piece, we have 4 outer facets, right? And 2 of them are covered in this gorgeous kind of like kunzite druzy. Now, if you guys don't know what a druzy is or what that means, basically it means that it's another kind of term to describe a stone covered in tiny little stones. So a tiny little cluster. So each cluster, or each little cluster of druzy, would have a bunch of tiny little microcrystalline crystals of kunzite. So it kind of looks like sparkle dust or something. It's the best way I can explain it. But basically what it does is it makes this wall that light cannot pass through. And so because we have these 2 other sides that are clear, the light comes in, and we're able to really kind of, it adds contrast. It lets us see into the stone and see the really true beauty and brilliance of it. Oftentimes with microcrystalline fractures, you don't see them too well, especially if it's just entirely clear. The fact that you have the druzy on the other side adds that contrast to let you see the stone, which is kind of nice. But yeah, this piece is just absolutely gorgeous. I'd say it's probably one of the highest quality pieces of kunzite that we have, and it's only $55. Mind you, it's not really, the size doesn't matter, right? It's really just about how high quality this stone is. If it was bigger, man, it would be like probably twice as much as the largest one here, which is $125. So yeah, no, this specimen here is absolutely gorgeous, and you can even see, look at the way the light plays in the stone. Absolutely gorgeous. Again, $55 for this gorgeous little specimen. A piece like this would also come in a nice, like, little display case, so you wouldn't have to worry about it, like, you know, I don't know, break-in or something like that. This would definitely be a nice piece for a collector, so definitely very nice. If nobody buys it, I'm going to buy it. Alrighty, that is our kunzite. Let's continue on here. Alright, so next, I think what I'm going to show is I'm going to show some of our newer specimens. So, we recently got in these really pretty pieces of pure silicon, and I just love them. I mean, I think any kind of metallic mineral or anything is just gorgeous. So, I love it. Let's take a look here. Alright, so these pieces here are $18 each. Now, pure silicon is not found in nature. The way it's formed is by getting silicon carbide and melting it to above 22 or 2500 degrees Celsius. And the carbon will melt off and burn off while at least behind the pure silicon, and that will melt into a crystal, and or like a liquid, and the liquid will cool into a crystal, leaving behind a gorgeous metallic piece of silicon. So I'm going to show you guys these here. It's very similar to another metallic mineral that we have called galena. Now, as you can see, it's very, very shiny, right? Look at that. So you can even see, this is one of these, probably one of the sides that it was cooling or crystallizing on, probably the surface. So usually these would be melted into, like, in a pot of some kind, or some sort of like smelting pot. And this is the surface that has been crystallized. Look at that. So that is the crystalline structure of the silicon. As you can see, it's metallic in luster, and it basically breaks conchoidally, breaks like glass. It's very brittle, and it's also very light. Silicon is one of the most abundant elements on the planet Earth. We are a very silicon-rich planet. And it looks like this little dark spot here, this is some leftover carbon that wasn't burned off completely. Yeah, these are absolutely gorgeous. I love this. Now, these are all $18 each. Definitely one of those really cool, like, you know, specimens that kind of show your friends, you know. If you want something kind of like a cool display piece for your kitchen or coffee table or whatever. Yeah, I absolutely love these. Now the color itself too is kind of interesting. So if people are familiar with galena, galena is lead ore. And lead ore, the color of galena is like kind of like a steel blue. This is kind of like a steel blue color. Clean off the lens here. Getting a little dirty from all the rock dust. There we go. That's a little better. But yeah, the color is pretty similar, which is kind of interesting. Now, this is something you don't normally see too often. This is probably something that you'd find, like, not in a novelty store. Definitely not in a gas station stop somewhere. This is something that's, like, usually, like, an educational tool. So, I think we had even ordered these from an educational site, which is where you'd probably find them. I mean, having things like this to kind of teach the younger generations about, you know, chemistry and geology and science, it's very important. Now, I love that crystal habit there. Now, if you guys are wondering, like, okay, so, you know, obviously we try to find out everything there is to know about all of our specimens, right? We care about it all. The science behind it, the geology behind it, the story each one has, the history behind each one, human history, the metaphysical side of it, the spiritual side. So metaphysically speaking, pure silicon is basically the same as quartz. I've heard that it's a little bit kind of like a softer kind of quartz, basically, so it's not as like powerful as quartz crystal, but it's kind of like a softer kind of version of that. Now, what's kind of interesting about this specimen here, again, these are all $18 each. We have, obviously, you know, the crystal structure here, silicon, and then we have some kind of, like, it looks like quartz, basically silica, probably some sort of flux that was put on the piece when it was melting, which is kind of neat to see that. Now, the darker areas, the dark gray or brownish, you know, maybe spots that you might see on these, like on this piece here, that is the leftover carbon. Because remember, silicon carbide, I think it is. Something like that. It's basically silicon and carbon, basically, and the carbon is used to kind of separate things out a little bit, and it's also used as a flux as well. But it's interesting to see how these are made. Like, most people would probably see these and say, well, you know, like, you know, either they'd either say it's man-made, or they'd say, well, like, oh, it's like all natural or something. It's definitely not all natural. Pure silicon like this does not like form naturally on Earth. at least at this scale. Maybe on like a very, very tiny, like microscopic scale, you might find one pure silicon crystal, but never like this, never massive like this. This does not occur here on this planet. Yes, we are staying cool. We are trying to. For those that don't know, the southwestern part of the country is experiencing a massive heat wave. It's very hot and humid here by the coast. So, and out in the desert, it's like here it's supposed to be getting out to 120. Insane. So we're definitely staying cool. Surfing is one of our pastimes here in California. So we will definitely try to stay cool out in the water. That is always fun. Obviously with appropriate PPE and all that good stuff. Got to stay safe out there. Yeah, these are really beautiful. Again, they're all $18 each. And yeah, they're really cool. We just got them in the other day. So it's one of the sucky parts about the pandemic is that we can't really get a lot of new material, you know, which sucks. I had gone on a small rock hounding adventure a couple weeks ago, and it was interesting. I mean, there wasn't a lot of people. There hasn't been a lot of people out on the road or out and about, especially out in the middle of nowhere. Rock hounding is probably the most socially distanced activity you can find. I mean, basically, it's just me and the desert, or the woods, or wherever I am. But yeah, it's definitely something I miss doing. I wish I could do it a lot more often now. Yeah, I was recently looking at some pictures, old pictures of mine, and found a picture of me in an abandoned mine looking at some sort of mineral on the ceiling of an abandoned mine somewhere. It was like probably a copper mine or something. There's some turquoise everywhere. I just love doing that kind of stuff. Definitely would not recommend it for people who are not experienced. So, just a heads up. Alright, so, this next specimen I'm going to show, look at this. This is an amethyst point. This is $89. It's a massive amethyst point from Brazil. Imagine the cluster this came out of. Must have been massive. So, most of the amethyst mined in the world, it comes from Brazil. Brazil's geology just yields amazing specimens like this. For some reason, you know, lots of like volcanic material. Usually, these are going to be found in like kind of like igneous rocks, like basalt or maybe andesite. You need high amounts of iron to form amethyst or citrine, and you need lots of pressure. So especially for these larger crystals, lots of time and lots of pressure. So remember, you know, for those who've taken a geology course, what is the first thing you learn? You learn that, okay, so we have this glorious scale, right? We have a scale. On one side we have heat, and on the other side we have time, and then we have pressure. And so all of those factors play a role in crystal formation. So if you have a big, you know, pluton underground that's coming up, percolating from the mantle through the crust, and it's all hot and molten, if it gets lodged in the crust and does not continue to the surface, what will happen? It will start cooling. And if it gets stuck down there, it will cool over time. And the longer amount of time it takes to cool, the larger the crystals will become. And you need pressure to do that. You need heat. You need heat over a long period of time, but you, of course, need a lot of time to cool. That is what you need to have these crystals grow. These crystals are just amazing. You know, for people that have probably seen those huge crystal caves, like the one down in Mexico where they have those very deep in the crust, and it was like some kind of mine, and they opened up this pocket, and they found this cavern full of these like massive 40 or 50 meter long selenite crystals, like something the size of a school bus. That is incredible. That's something that's like a natural wonder of the earth. There are things like that in the planet. They're caverns of just amethyst that are the size of a house, probably. There's one, actually, I'm not too sure where it is. I don't know if it's moved. I know it was in Brazil for a while on display. It might be like somewhere in the States now, but it was a huge cavern that you could go inside of and like sit in. Like, that is awesome. I think that's amazing. Something that massive. We look at the other side here too. Kind of pretty, you know. Again, $89 for this massive big boy right here. Next, we're going to take a look at some calcites. So, I love calcites. Calcites are cool. Calcites are very unique. So, remember, calcite is an evaporate mineral. So that means you need to have water present, and the water needs to be evaporating for calcite to form, or for any evaporate to form. Now, calcite, it's going to form in, you know, obviously areas where there's water. So wherever you have water, you have sedimentation. So you have runoff coming into a lake, or like a stream, or a gulf, and all that sediment will just layer out over time, over millions of years. Millions and millions of years. And over that course of time, what will happen? You have these things called transgressive and regressive cycles, where the sea level will rise and it will drop, rise and drop. And that happens over the course of hundreds of thousands of years to millions of years. During the Ice Age, our last Ice Age, we're still in the Ice Age. We're in a semi-glacial period. So we're in between Ice Ages. We're moving into a warmer period now. But our last Ice Age, sea levels had dropped significantly because the water was locked in the glaciers. Now, when you have the glaciers melting, sea level rises again. Now, when that water leaves, it will leave behind, and it will evaporate and leave behind things like gypsum or calcite. And whatever layer of sediment was in there, whatever chemicals, whether there was lots of iron or lots of cobalt or sulfur or this, that, or the other thing, copper, whatever was left behind, it will be crystallized and locked into the calcite. So, for example, we have these calcites from Mexico, and these are from around the Mexico City area. Now, for those that don't know, that whole area used to be an inland sea. It was covered in water. Now it's not anymore. And when it was covered in water, it left behind like tons of sediment from all over the place. There were mountains on all sides. Some of the mountains had different chemicals and different elements and different minerals. Those get washed out into this basin, kind of. And when the water would recede, it would evaporate and leave behind a crystallized layer, which would lock all those chemicals in there. So, for example, we have lots of reds, that's iron. Some greens, maybe that's some copper or chromium. Black, we might have some manganese. So depending on what you have, what's in the sediment, you're going to have different colors. What's unique about Mexico City, in that whole area, that region, is that you had sedimentation going on for millions and millions of years, and you had like regressive and transgressive cycles. The water would come in and leave over the course of millions of years. And what happened is that you had this huge layer cake of calcite building up over and over and over again. And there's like a mile or two thick layer of calcite in that region. And so basically all these pieces here, like for example, this piece here is only $36. Now imagine you have this gorgeous red piece, right? Well, right on top of that, imagine finding something like this zebra calcite, which is $48. Look at that. So these are all found in the same place. Literally like right on top of each other in the same area. And so a lot of these, it's just because of what was being deposited at the time. Some moments in time there was more iron being deposited. Some moments in time there was more manganese being deposited. So depending on what was being deposited at that time in history, that shows you that you see that literally in the calcite layer. It's like a record. So each tiny little microcrystalline layer, you can even see it really well because of the contrast to the zebra calcite. Each one of those layers of crystal, each line, is it signifies a certain amount of time. And so I'd have to do some research and look it up, but I know for a fact there's geologists that have mapped this and could probably give some sort of estimate as to per centimeter or millimeter of crystalline calcite, how much time does that represent? And you could measure it out. I mean, you can also, you could also date these as well and figure that out, easier. But still, I mean, it's pretty fascinating. So again, we had our red calcites, and I think what I'll do is, after explaining that whole long spiel, which I think is entirely fascinating, I love it, I'm going to show the red calcites first, and then I'll go from color to color to color. So we have our red calcite. This is the last one that no, actually I think is the last one. No, this is our other red calcite, I guess. This piece is $58. These are all priced by weight. As you can see, it's just absolutely gorgeous stuff. The layering is beautiful. Now, the calcite, the luster that you see on here, it's not covered in anything. This is basically a polish. So when you break the calcite, it's a crystalline, basically luster. It's very shiny, but because it's so soft, it gets scratched up and stuff. So for display purposes, these have been kind of lightly power washed to make it all shiny and beautiful. So that's kind of what has been done here. Again, this piece is $58. Next, we have this other one that we showed earlier. This is a $36 piece of red calcite. We have gorgeous layering in there. I mean, when you look at these layers, I mean, that's millions of years of history right there. Whenever I hold a rock, I just think about that. I think about where it's been, how it formed. Whenever you hold just a pile of sand in your hand, just think about that. And then at the end of the day, where did that all come from? The Big Bang. Everything came from the same place. So it's very humbling, thought process. All right, and we showed this gorgeous piece of zebra calcite here. Again, this looks like taffy. Everybody says it looks like candy or cake or something. It's very pretty. The top is really beautiful too, very marbly. You can definitely see why it's called zebra calcite. Got some zebra stripes. Next, we're going to look at some champagne calcite. Now, these are really nice because they let a lot of light in. I'm going to show the smaller piece first. This is a $16 piece of champagne calcite. Now, is it champagne? This might actually be one of our other varieties. Oh, darn it. There's so many. Each color has a name. But I think this is probably our champagne. Now, we have the yellow, right? Yellow striped calcite. No, is it yellow striped? I think it is. Yellow striped calcite. Now, the yellow, that's a little bit of iron. So, depending on the iron ion, you're going to get a lighter color, possibly. If there's not a lot of iron, maybe you're going to get a lighter yellow color. The dark bands, that is manganese. Manganese, you're going to find wherever there's water evaporating, or wherever you have cold, dense water. On the ocean floor, you can find these really interesting structures called manganese nodules, which are these little balls that form on the ocean floor, just made entirely out of manganese. So they're just kind of cool. This next piece, though, this is the creme de la creme. This is absolutely gorgeous. I love this. I'm going to kind of set it down here. Now, this is a piece that I would love to turn into a lamp or something. If nobody buys it, I am going to turn it into a lamp because it is gorgeous. Look at that color. Look at that. That is absolutely gorgeous. $52. And what's really neat is that it lets a lot of light in. So if I hold it up at an angle here, just above our little light box here, I might even be able to show you guys. The light comes right through it. Look at that. It's like looking through an orange slice. It's absolutely gorgeous. Really, it's just an amazing piece. As you can see, it's really kind of thin. So it lets a lot of light in, and it's also very crystalline. You have a lot of this, basically this thick, translucent yellow band here. But I mean, this is such a nice display piece. I mean, basically you have this nice polished side here, and you can just set it down on your shelf or something, just like this, I mean, it's absolutely gorgeous. A beautiful piece. I love this piece. And another one of those pieces that if nobody buys, I'm going to buy. So, $52 for that. Next, we have green calcite. Now, the green calcites and blue calcites that you see, the deposits, they're basically being exhausted. So because, we have this layer cake of calcite in Mexico, right? They start mining from the bottom. They start mining from the top to the bottom. And so the top layers, the first layers they're finding were the blue calcites, and then the green calcites, and then the red calcites, and then the yellow, and the yellow striped, and the zebra, and so on and so forth. Now they're finding purple and all sorts of other ones. But once those layers have been exhausted, that's it, at least for that area, that region. That region is world famous, world renowned, for its basically variety in calcite, all in the same location. Now, this piece here is $45, and green calcite is really gorgeous. It's a lot more dense than other calcites. I used to have a piece that I wore as a necklace, so you can actually use it, in jewelry or whatever, and it's really just pretty. Now, again, these are all grandfathered prices, okay? So the cost of the blue and the green now has gone up significantly. So if you find anything like this size, just for $45 or cheaper, you're lucky. That's a grandfathered in price. Because I've checked, and prices have been going up significantly. So that tells me that the deposit's being, exhausted, sadly. Next, we got this smaller green calcite here, $26. In the green there too, just seeing the light coming through. Translucent stones are amazing. They are just great. I love it because light will just come through and kind of just light up the whole piece. Pieces like this, I would love to have just install a light inside of, because they would just glow beautifully. Yeah, absolutely gorgeous. Again, $26 for this amazing piece. Next, we're going to look at some blue calcite, and that should do it for our calcites for today. This one's a bit heavier. We recently had an order for a lot of blue calcite, and we have to sadly cannibalize one of our gorgeous pieces of blue calcite for this order, but hopefully it's not this piece. So this piece here is $38. Look at this big guy here. It's pretty massive, pretty heavy. Now, blue calcite just in general is pretty common. You're going to find this all around the world. It's one of the most common kinds of calcites beside ice and spar, which is just normal white calcite color, basically colorless calcite. Now, if we take a look here, on the other side we have these gorgeous veins of iron oxide deposits. This tells you that it formed near the surface where there was oxidation going on. So that should also be another clue too why the blue calcite was the first calcite to be found in Mexico City. So when you have the initial layers of calcite, you're going to have basically colorless, and then it's going to go into blue. The colors, obviously you have to have different elements to have those colors, but metamorphism also changes the arrangement of those chemicals, those elements within the molecule. So what can happen is that if you heat up and pressurize some of this calcite, it will physically change. Probably change color, maybe change shape. So a lot of these have been cooked underground by the earth. because of tectonics and stuff like that. But yeah, so these are absolutely gorgeous. Love the blue in here, very bright. Alrighty, so next, what are we going to show? Probably show some other cool things. Since we have a lot of cool things to show. Let's see what we got here. Oh, we got some quartz points. Now, these are probably from Arkansas. These are $4 each, pretty affordable. I like that. And these are about 2 inches long. They're all pretty decent quality quartz points. $4 each for these though. That's pretty good. So normally for diameter, large diameter points like these, yeah, I would expect anywhere else probably $10 to $15 each maybe, unless you're buying bulk. Yeah, these are absolutely gorgeous. Very good quality. And we even have some crystal habit growth here. So we have those striations, right? So those striations in the kunzite that we saw earlier, that had to do with the crystalline structure of the stone. However, with these lines that you see on the side of the stone like that, whenever there's light reflecting off of it, those are like little growth lines, like tree rings. So when you have a crystal growing, what happens is that you have the chemicals, the elements, they organize into a molecule, a crystalline structure, and it replicates. So it will, another layer will grow on top of that already there crystalline structure. And since it's already there, so we call that initial crystal a seed crystal, and then once the crystal just takes off, layer after layer after layer will grow on top of that crystal, and end up yielding gorgeous pieces like these points. The rods, those single-dimensional crystals like tourmaline or kunzite, they're basically growing in these octagonal shapes, like these cylinders, which are growing just in one direction, straight up, and they grow right next to each other, all at the same pace usually. So we have all sorts of these. And just as a reminder for you guys, if you guys see anything on here that you like, just leave a comment in the comment section. Let us know. We're streaming on YouTube, Twitch, and Facebook today. And if you're watching this as a video on demand, because after the stream is over, these are actually automatically uploaded to YouTube. So if you watch any of our prior streams, you can take a look at what we got and say, hey, is that specimen from an hour and 20 minutes into the stream still available from June 20th? And we'll say, yeah, it is. You want it. So definitely we can do that kind of thing too. Just so you guys know it's there as a resource. We have a ton of specimens. I mean, we probably have thousands and thousands of specimens. Now these last ones, I think I'll show maybe 2 more, and the rest I'll kind of show all at once. These are pretty nice quality. Now, just look at the quality of the quartz there. Hardly any fractures. Absolutely gorgeous. These are nice too to just carry around with you. If you want a piece of quartz crystal for your purse or your car, or for jewelry making, this would be like a nice decision, a nice choice. And also too, just as a gift. I mean, I give rocks as gifts like all the time. People, if I don't give somebody a rock as like a gift for the holidays, man, like, it's all over at that point. It's like, what's wrong? What happened? Now this piece here is kind of interesting. It's almost like we have like an interesting double termination here, which is odd. So this is obviously double terminated. Basically means that we have 2 points. Terminus, the center of. So basically we have all the facets coming together into this one terminal, which is the point of the crystal. And we have another point here, which is very fascinating. That is very uncommon, especially for quartz crystals like this. Usually you see these where there's lots of heat and pressure, or if you have lots of carbon in the ground, the carbon can affect the growth of the crystal. So this is a very unique point here. Very unique, and it's only $4. Alrighty, these last ones I'm going to kind of just show all at once here. As you can see, we have so many quartz points. Look at all this. I mean, they're just gorgeous. So these are kind of like the size. They're anywhere between like 1 inch to 2 inches long. I would say that these are like anywhere between AA to like AAA in quality. Some of them are AAA, some of them are not. These are just nice quartz points just to have, kind of put around. Leave as a gift somewhere for somebody. Next, I think I'm going to look at what we got here. We have some tumbled amber. I wish I had my black light with me. It's on my workbench in our workshop. So amber, for those that don't know, amber will fluoresce different colors under a black light, and that's how they're graded. So depending on the color of the fluorescence of the amber, that will determine what kind of quality you have, among other things. Now these pieces of amber here, these come from Sumatra, and they're absolutely gorgeous. One of them has a pretty nice, like, kind of microcrystalline fracture, which doesn't even go through the whole stone. It's kind of nice. So we're going to take a look at each one of these, and as you can kind of see, they're like pretty dark red, dark like amber colored. So I don't know if I can maybe shine this up to the light here. Can't really see through it. This is a pretty dark colored amber. If you held this up to the sun, you'd probably be able to see through it. Now each one of these pieces is $8 each. This piece has a little more clarity. You can kind of see that amber color kind of shining through here. Now let's see if I can maybe get a better look here at this specimen. There we go. That's what I want. All right, so you can definitely see that. Look at that. That's absolutely gorgeous. That nice red color. Absolutely gorgeous. Now, with a black light, you can see all sorts of other things too. Some features that you wouldn't normally be able to see under just regular light conditions. This piece here, let's kind of shine this up. Look at that. So as you can see though, it's fairly dark amber. Very rich in color, but the color itself, when you see that color, it's like a beautiful like amber red. Really pretty. This piece is probably one of the most clear pieces that we have. It's kind of like a cabochon already. A cabochon is just basically a rounded stone on the top with a flat back, perfect for setting in jewelry, that kind of thing. Now, most of our amber is going to have some kind of insect life in it. These pieces, I don't think have a lot of that going on, but we do have some higher quality amber from South America, which does have a bunch of insects in it, if you're looking for that. Now, my helper today handed me his blacklight, so I got this. We're going to take a look at these in under a blacklight and see what happens. So, let's do it, right? So we got the light off, and I'm going to show that dark one. Now here's that dark piece of amber, right? Let's take the black light, I got that right here, and let's shine a light on it. Whoa, there we go. So look at that. So there's some features here that weren't visible before. Some dark spots, some layering. So the brighter the color is, the higher grade it usually is. So, because that indicates clarity. This is a pretty opaque amber. That's probably why we couldn't see a lot of light through it. And so this dark drabby green color, this would be kind of like on the other end of the spectrum, kind of lower quality amber. Now if we go up the scale, this is that one that we did see through it. Now look at the color change though. We have that drabby green, but we have kind of streaks of lighter colors as well. Look at that. That's pretty unique. So those lighter greens and the lighter blues, that indicates a higher quality amber. The second one, or sorry, the third one that we saw, this was more translucent one. Look at the color now, even higher quality, more of a lightning blue color. Now, this is more consistent. I'd say this is a double A grade amber. Let's take a look at that. So, and the fluorescence really does help you grade the stone because it lets you see those imperfections that you normally wouldn't be able to see otherwise. It's one of those tricks that, you know, a lot of people don't really know about. There's this kind of amber called blue amber from Argentina and South America, and blue amber will actually fluoresce a lightning blue color, which is very uncommon. That indicates that it's very high quality, no perfections at all, there's no imperfections at all. And this next piece I'm going to show is very similar to that blue amber. Take a look, and it's called blue amber because it fluoresces like blue, like lightning blue color. Now look at this blue here. This is fluorescing a bright, bright blue. You can see that. You could even see before what kind of quality you're dealing with, right? But the black light really reveals that it's AAA quality. This is AAA quality amber right here. Absolutely gorgeous. Now, if you want to get a black light, there's a ton of cool black lights on the internet you can find. Ours were totally inexpensive. They're just like little handheld flashlights, basically. But you can get some pretty high-powered ones that operate at different wavelengths. Some are very strong, so you have like long wave and short wave UV. So depending on what you're looking for, you know, you can use either or to, depending on, you know, what kind of strength you want. All right, let's plug this light back in. Now, currently we don't have any blue amber in stock. I have one piece that I was gifted. And it's just the most gorgeous thing in the world. I plan on setting it into the hilt of a sword one day. That's my plan. All right, so next I think we're going to look at what's in this flat. What is in here? Just as a reminder for you guys, we have about an hour left of our stream. Just as a heads up. All right, this is what we got going here. We have some cubic pyrite from Spain. Now, cubic pyrite is natural, forms naturally as a cube, almost a perfect cube, and it forms in limestone. Now, it comes from a place in Spain called, I think it's Nazca, Spain. And the people we get this from, it's a Spanish family, and their mine has been, it's actually, their mine is like one of the only mines that operates in that area. They've been mining this stuff for quite a while, probably a couple generations at this point. So this cubic pyrite, take a look at this. It's still in the matrix. So the matrix is basically the rock that formed it. Now, I usually like to show people something like this. I know I have a piece of cubic pyrite here. There we go. So, this is a pretty large cubic pyrite cluster I got right here. This is just one of the pieces on my desk. Now, people usually see this and they say, wow, this must be man-made. Nature can't create something so perfect, but it can. So, I usually show people the clusters first and ask them, what do you think? Do you think this is man-made or natural? And some people say natural or man-made. Most people say man-made. And then I show them one of these in the rock that it was mined in. And mind blown. They're like, wow, the heck? How could this be real? It's kind of like, it's entertaining, kind of like to think about that, you know, and looking at like the pieces that we showed earlier of the pure silicon, those are gorgeous, and maybe one would expect that they could be natural, but at least on this planet, you're not going to find pure silicon crystals like that. They are man-made. These are natural. It's an interesting little thing. So all of these are all $26 each. And some of them might have a little cube like that one. We have a tiny little baby cube in there. But each one of these specimens will have one cube. So the way these are priced, these are priced usually by size of the cube, quality of the cube, and how many cubes you have. So those are the factors that affect the price. These are definitely on the lower end. The lowest end that we have is just the cube itself, just a single iron pyrite cube. And those, oh God, I think they're $10 each, maybe a little bit less than that. And so kind of going up in value, we're talking about the piece within the matrix rock. Whenever you have a specimen in matrix, it will always be more expensive than the actual specimen out of the rock. It's just the way it goes. Now, take a look at these. Each one is just kind of like a little more unique and interesting. All of these should have a flat like surface that you can rest it on. So for example, we have a surface here where it's been carved or cut away. So these are great for like putting on your desk or somewhere like that. Metaphysically speaking, you know, you're going to use iron pyrite for grounding. Anything that is heavy, anything that is like, you know, has lots of iron or lead in it, it's heavy, you know, it's grounding energy. So if you feel like you're aloof and all over the place, pyrite will definitely ground you. And then also too, especially with a lot of these cubic rocks, if you want to stay more organized, or if you need a lot more like, you know, maybe some structure in your life, having something like that's a bit more of a cubic shape can help with that kind of thing too. So you might even notice too, we have two growth patterns here, right? We have a three-dimensional object. So the cubes are going to grow in either, you know, height, length, or width. So some of your cubes might be more rectangular, like this one. So it's a little kind of narrower from this dimension, a little bit narrow from this dimension, but wider on this dimension. Really depends. And then you might have something that's a little more perfect, where each side is basically equidistant, about the same size. Again, these are all $26 each. Pretty affordable. This one's more of like a kind of like a rectangle kind of. Take a look at that. How like reflective it is. I mean, it really is like a mirror. You can see my finger on that. That is probably one of the most reflective surfaces I've ever seen in one of these, especially one that's on the matrix. The ancient Egyptians and Romans and Greeks would use plates of silver or gold, or you know, basically some kind of like highly reflective metal, and they'd use them as mirrors. Very simple mirrors. Imagine being alive back then trying to make a mirror. Now, I don't know about you guys, but trying to have a very flat surface like that is like near to impossible. So a lot of those old mirrors, they wouldn't give you a perfect reflection. It would be more like kind of like a warped sort of a reflection. So it's definitely was an art to make something like that back then. What's kind of cool too, if you look at it in the angle, you can see that really interesting, kind of like circuitry almost. The crystal habit in some of these like metal crystals is absolutely gorgeous. You can see that in there, those little lines kind of like going around. Very, very cool. Alrighty, gonna move on to our next grouping of specimens here. Got all sorts of stuff. Now, once this whole pandemic blows over, we are going to be having some of our rock shows again. And if you guys live in Southern California, you can come by and take a look at everything we have. Literally, for our rock shows, we have everything out. Everything that we even have in stock. You can see our entire store, entire stock, literally everything. And we have a lot. It's a lot of work. Usually it takes like about 2 days just to set it up, and then it takes about 2 days to take it down, maybe a little bit longer. But it is worth it. It's fun. Get to share all these cool rocks with you guys. It's always fun to me. All right. Golden wolfenite. Wolfenite is a lead mineral, so you're going to find it a lot by Galena. And what's interesting about these golden wolfenites is, wolfenite in general is very different depending on where you find it. There's the Red Cloud Mine where you're going to find red wolfenite. There's Morocco where you're going to find orange wolfenite. In China, you'll find like bright neon yellow wolfenite. And then in Mexico, you can find these, which are kind of unique. They're like these golden yellow colored wolfenite specimens, just like these little sandwiches. Now, we made a post about these. I'm going to see if I can just quickly pull it up because it's the chemistry for these is just pretty interesting. Let me see if I can find it because I just really think it's really neat. Basically, you have this wolfenite and you have this the actual wolfenite crystal. I think it's the layer in the middle, and then the 2 layers on the outside is some other kind of mineral. I'm going to see if I can try to find it. This piece here is $45, and it's a pretty large piece. I mean, take a look at that. And the stone that we're looking at here, this is very fine grained. This is probably some kind of either a quartzite or an andesite. I would say this is an andesite, considering how dark it is. And also considering the fact that you're probably going to find a lot of metallic ores in volcanic rock, in like igneous rock. You're going to find it where there's lots of volcanism going on. So that's where a lot of that stuff is deposited. Again, $45 for this gorgeous piece. Take a look at that, though. I mean, just the clusters are amazing. Now next, I'm going to look at a kind of a smaller piece here. This piece here is $25. Take a look at that. Now these little crystals here are just gorgeous. Each one of these would come in a display case, so you wouldn't have to worry about displaying it, that kind of thing. And obviously the crystals themselves are pretty fragile. Definitely would not recommend dropping it or like putting a lot of pressure on the crystals. You might break them. It's very sad. It's a very sad day when you break a crystal like this. It's just absolutely pretty. Even the matrix rock that it's in is gorgeous. I mean, taking a look, just take a look at that. Shiny and sparkly. Yeah, and these are very difficult to just mine. Imagine, like, this is pretty hard rock. You would probably be working at this with like chisels, sledgehammers, and maybe when it gets small enough, like some kind of saw. Because these are all chips. These are all pieces of a massive boulder of some kind. And I would imagine too that there'd be lots of breakage involved. So mining like this is very difficult. This piece here is $30. Got a few more crystals here. Very pretty. Now I love these too. They're like little sandwiches almost. Now, the place where this comes from a mineral-rich region in Mexico, Durango, Mexico. And most of the mineral-rich areas or regions or just mineral wealth is found around Mexico City and Durango. So you're going to find all sorts of mineral specimens there. You're going to find like everything: amethyst, calcites, wolfenite, iron pyrite, galena, stilbite, fluorite. Every mineral you could think of, you're going to find in that area. It's like, if you guys are familiar with the mineral-rich region in Brazil, Minas Gerais, it's basically the Minas Gerais of Mexico. It is Durango. Now, this piece we featured on our Instagram, and I love this piece. It's one of my favorites. It's definitely one of those pieces that I'd probably say, you know what, I'm going to buy this if nobody else buys it. This piece here is $30. It's a very thin piece, very kind of like elegant, but look at the crystals on here. See how close I can get here. Just take a look at that. I mean, it's very fascinating just seeing these little sandwiches, you know, of wolfenite. I can't imagine getting these out of the ground. Like, sometimes I take a look at some of these specimens and I feel the pain. Now this next piece here, another $30 specimen, and we have some interesting druzy on here, and I want to say these are actually little fluorite crystals. Now this is just another example of the weird stuff you'd find in these regions. I mean, you have fluorite crystals, like cubic fluorite druzy, right next to like this kind of weird sandwiched wolfenite. I mean, it's weird. You find weird stuff down there, like weird stuff, which makes it very unique. There's this one specimen that we have. It was a piece of calcite. Was it calcite? No, it was some other kind of mineral. But there was some sort of mineral with halite on it, which is rock salt. And geologically speaking, it shouldn't have even existed. So it very, very kind of weird and peculiar stuff that you're going to find in these areas, these mineral-rich areas. But yeah, this piece here is gorgeous. Take a look at the back side here. These are nice for mineral collectors, for sure. Like this piece here, $30. I mean, it's affordable and it's unique. There's not going to be anything else like this on the market. You know, like, you're only going to find these in Durango. Nowhere else in the world. This next piece here, this is a $25 piece of golden wolfenite. Take a look at that. Big sandwich right there. And that's really cool, that little cluster in there. It's like a little cavern or a city. I mean, I love these. Absolutely love these. All right, I'm going to show one more, and then we're going to move on to our next little series of specimens here. This is a $30 piece of golden wolfenite. Take a look at that. Very pretty. And the contrast, yes, the contrast is very unique. The dark and the light. Having high contrast minerals is really cool. Yeah, I love these. All right, next we're going to look at probably some of our mortar and pestles, and then we're going to move on to our last flat, which will be our fine mineral specimens. Yep. And maybe if there's more time, some of our palm stones. All right, so we have these very cool mortar and pestles used a lot for medicine, for cooking, for herbalism. Now, a mortar and pestle is one of those things where, you know, if you're really into cooking, for example, I love using one, especially for spices. I'm going to set these up here and lay them out because these are gorgeous. So these are all going to be the same price. These are all $20 each. And they're all different materials. These all come from Mexico. And what I'll do is I'll kind of orient this down so we can kind of take a look at all of these. There we go. This is the last one. So these are all types of onyx. Onyx is another kind of like evaporate sort of mineral, very similar to calcite. It will dissolve in hydrochloric acid. That's how you can tell if something's a calcium carbonate or not. And we have basically these different varieties here. The onyx is basically cementing this stuff together. So it's called onyx. Onyx is high in silica. These are probably more like onyx. These white veins here, that's calcite. Calcite is going to be cementing everything together. These are fractured or brecciated rocks. This is all calcite. People are going to call it just onyx, just because, you know, that's just the colloquial kind of like grouping that they're in. But these would be more like a jasper, probably. These are brecciated sediments. But take a look. I mean, these are all $20 each. Very, very pretty. Very unique. And these would be a nice kind of gift for somebody who's either into, like, you know, alchemy, herbalism, cooking. And mortars and pestles have been used for thousands of years for, like, just medicine. You know, I mean, doctors still use mortar and pestles to grind up certain things for medicine. So it's just one of those kind of like staples of humanity, one of those tools, which is kind of cool. But yeah, these are all $20 each. We have our red onyx, we have our zebra onyx, and then we have our, basically our just regular white onyx. These are all very, very pretty. And just the striping in this clear kind of like calcite-rich onyx. I mean, take a look at just the striations in there. The strata, absolutely gorgeous. Imagine putting one of these in your windowsill. Light right up. Alrighty. Move these aside, put these away. We're going to move on to our fine mineral specimens, which are probably one of my favorite grouping of specimens that we have. Now, when it comes to our fine mineral specimens, we have stuff from all around the world. These specimens are pieces that are extraordinarily just unique. You're not going to find them in any of our other flats. They're not like normal by any means. They're very unique. They're mineral collecting samples or specimens. So you'd find these like in a museum probably, or in somebody's rock collection. They're pieces that you'd want to put on display. And so all of our high quality mineral samples are all going to be in that collection, our fine mineral specimen collection. So I'm going to put these away finally and get into that flat. And I think at this point we probably have like, I don't know, I want to say like over 10 fine mineral flats. So not like a ton of them, but quite a few. Each flat probably has about 20 to 50 specimens. This one here is a bit heavy, so I think, yeah, this one here probably has 18 specimens. So we're gonna open this up and take a look at some of these. And this should probably keep us occupied for the rest of the stream. Alrighty. Alright, first of all, we're going to show this gorgeous piece of malachite. This is malachite from the Congo. This is a $32 piece, $32 sample. Close up there. Now take a look at the fibrous appearance, the fibrous crystal habit that we have. So this crystal habit, right? This is just basically telling us that we have something in the environment that is causing this to grow this way. So malachite usually is going to grow in layers, be very, botryoidal, so bubbly kind of, not fibrous like this. It's very fibrous and shiny. So what causes this is high amounts of silica. So malachite is a copper carbonate mineral, and usually it doesn't have a lot of SiO2 in it, but if you do have SiO2, it's going to change things radically. It's basically going to make this just grow out into a bunch of different rods. Normally what would happen is you'd have chrysocolla. Chrysocolla is basically just a copper-rich silicate mineral. Instead, this is still a copper carbonate, but it has silica in it. So this would be considered a silicate. Again, that was a $32 specimen there. And then we have some of this gold. Actually, I think I'll focus on this one first. So this is another piece of malachite and chrysocolla. Very similar. This is also from the Congo. Take a look at this. So we have quite a few, quite a few different minerals here. We have on the bottom here, we have some kind of like igneous, like volcanic rock, probably rhyolite. And then right above that, you see that lightning blue layer right there, closest to the rock, right by my thumb? That is chrysocolla. Above that, we have malachite. And then on top of the malachite, we have turquoise. So turquoise is going to be a softer blue color, and then the chrysocolla is going to be a lightning blue color. Malachite is going to be lighter green to darker green. Now, on top of this, these could probably be malachite crystals, again, like the fibrous malachite that we saw earlier, but just concentrated. And because they are pretty green, if they were blue, which I would expect, they would be azurite, which is another copper silicate mineral. Now, the Congo is very copper rich. That is one of their national metals or minerals. I think their national mineral is malachite. They just have lots of copper in their nation. Now, the specimen here is $30. A really nice specimen piece. Definitely a pretty good price too. We're gonna move on to our next specimen here. Next, we're gonna look at this beautiful piece of pyrite and galena from Peru. This is mostly just galena, but galena and so lead ore, galena, and iron ore or iron pyrite, for example, they're usually found together. And you're going to find them usually in like volcanically active areas. So for example, we have this gorgeous sparkly specimen here. Very pretty. Love this. So this is galena, and then on the back side we have our pyrite. An interesting combo. This specimen here is $25. Pretty good price for this kind of high quality crystal, especially with all those facets. Usually you're going to see galena in the cubic form. In this case, it is not in the cubic form. Next, we're going to look at some of these really cool specimens from Malawi. So these are smoky quartz specimens, azurine specimens. So this piece here has smoky quartz, azurine, and feldspar. Let's take a look at that. Absolutely gorgeous. Now we obviously have the smoky quartz there, right? But we also have azurine. Azurine is kind of like a very, very dark mineral. It's kind of like a dark forest green color, which is basically what this is, this little specimen here. And then the white crystals in here, those are crystals of feldspar. So this is something you would find in an area where you have igneous rocks, for sure. This piece here is $40 from Malawi. A very gorgeous piece. Absolutely love this. Alright, next we're going to show some more azurine. This is also from Malawi. This is a $48 specimen. Now these specimens are like mineral collector specimens. These are pieces that you're probably going to want to like put into a display case or something. I love these crystals because they look like a little city. So we have plagioclase feldspar right here with these gorgeous rods, like these towers of azurine. Just imagine the work it took just to get these out of the ground. Probably took a lot, for sure. Again, this piece is $48. And you know what? It's like, I love these kind of specimens. They're great to put on your shelf. I mean, if you want to start a mineral collection and you want like something that's kind of like out there, something that's a little exotic or rare, this is definitely like a good starting point for you. All right, next we're going to show this gorgeous piece of Mexican agate. It's $19. Showed this last week, and it's absolutely gorgeous. Just take a look at the banding in this agate. Absolutely gorgeous. I love that you can see the rough side and then you have this polished side. Agates from Mexico are just beautiful. There's a lot of volcanism in Mexico and Central America, and so that yields a lot of ash, and you're going to have a lot of like cool sedimentation going on, lots of really cool layering, lots of colors. So a lot of that is going to be yielding a lot of really pretty agates, a lot of really pretty stones. So we can definitely see that in this specimen here for sure. Again, this piece here is $19. Not too bad, not too shabby. Next, we're going to show some Cobaltian calcite. This stuff here is from Morocco. And this Cobaltian calcite is very pink. Very, very pink. And we have lots of manganese on it too, which is kind of neat. Take a look at those dark crystals. Those are crystals of manganese. And then you have our gorgeous, bright pink, lithium-rich Cobaltian calcite. Now this specimen here is $24. That's not bad for a piece like this. Usually Cobaltian calcite is going to be pretty expensive. See if I can get a close-up here of some of these crystals of the calcite. Now I had the opportunity to test this test it with some hydrochloric acid, and it does not fizz very violently. So to test it and see if something is calcium rich or calcium carbonate rich, sorry, if it's calcite, it's going to fizz when it comes in contact with hydrochloric acid. Depending on how much carbonate material you have inside the stone will determine how it fizzes, and also if it's a very silicate structure, it won't let a lot of the acid in. So something like this probably would not fizz that much. This is a $32 piece of Cobaltian calcite. Look at the pink in there. That is absolutely gorgeous. Looks like we even have some galena in there too, because these are pretty heavy. Yeah, that's absolutely gorgeous. Now, so this is not like a very rich carbonate mineral, but it is still considered a calcite, even though it looks radically different from calcite. But this is probably one of the pinkest specimens that we have. I'd say it's probably one of the prettiest that we have of Cobaltian calcite. Absolutely gorgeous. Again, this piece is $32. Look at that. Beautiful. Absolutely beautiful. This next piece here, another $32 specimen from Morocco. It's another piece of Cobaltian calcite. Take a look at that. I mean, it looks like candy. I would not recommend eating it, though. Yeah, the pinks in here are absolutely gorgeous. See if we can get a close-up here of the crystals. Yeah. One day we're going to get our butts to Morocco and do some mining. That'll be fun. Alright. Last but not least, the gorgeous blue chalcedony, or chalcedony, from Malawi. This chalcedony, or chalcedony, is very beautiful. It's a nice, sweet baby blue. Very light blue. It's almost like the color of a cloud, or a thundercloud. And the druzy in this is absolutely gorgeous. Just look at that. This is absolutely gorgeous material. This piece here is $30. Now the druzy on this just amplifies the presentation of the stone. It is absolutely gorgeous. And just the soft color. I mean, it's just like, it just stands out. I just love it. This next piece is also $30. From Malawi. And again, more of that druzy. We even have this nice layering going on here. You can see that. And it just looks like ice. I mean, something you'd see on a glacier or something. Yes, it definitely looks like blue snow. This last piece here is a $20 specimen of blue chalcedony. Look at this. Now, this is really neat. I mean, it's just all druzy. But look on the other side. You have this gorgeous layering here. You can see the difference here. We have this very blue, very rich, kind of pale layer of chalcedony there, and then on top of that you have just silicate material here, just a druzy layer. I mean, it's a very defined line, and it just lights up. And just look at the contrast there. Absolutely gorgeous. All right. So I think what we're going to do, it wraps it up for our fine specimens. We're going to look at probably a couple more palm stones and then end on that. I think what I'm going to show is I'm going to show probably some of these amethyst ones here. Let's see if we have amethyst. Oh, tiger's eye. Tiger's eye and lapis. I think that would be a good one to use. Okay, there we go. I'm just going to go straight to that. All right. So we have these tiger's eye palm stones, which are $7 each. And these are, again, all pretty different. Just take a look. Look at that. Now, tiger's eye, you're going to have that cat's eye effect, right? So these are very iron-rich rocks. And tiger's eye has these fibrous layers, which are just going to catch the light so beautifully. Tiger's eye is another really grounding stone. Definitely very dense and iron rich. In China, tiger's eye is used for a lot of different things. It's kind of like a good luck stone. Most people in Asia have a similar belief that tiger's eye can offer some focusing abilities. So if you need more focus or foresight in your life, something that can help. And some of these are just absolutely gorgeous. I mean, take a look at that. Those dark lines there, those dark bands, those are bands of iron. And just the way this shimmers in the light. I mean, just take a look at that. Absolutely gorgeous stuff. And these are just wild. I mean, look at that. Now, these bands here, the fact that they're all just rippled and rolling around, that indicates lots of folding. So these rocks were pressurized. They were forced together somehow. Lots of little fractures, resedimentation. Absolutely gorgeous stuff. I mean, some of these are just so magical. Alrighty, I think we're going to show 2 more of these, and then we're going to wrap it up for the day. Kind of a chill day today. Hot. Usually, just hot all over the place. Apparently it's getting pretty cold in the southern hemisphere. Hopefully our folks and our brothers and sisters down in Australia fare some better weather. These come from around China, I think. A lot of tiger's eye in the market does come from China. Most of it's very blue in color, though. Yeah, these are absolutely gorgeous. Again, those are $7 each. And as always, I am Mark Johansson with Midgard Mercantile. And we hope that you have a blessed rest of your day, a great week. We will see you next weekend. And yeah, if you see our video on demand, our live stream, which will be uploaded to YouTube, just check it out, look and see what kind of catches your eye. If you see anything that you want, let us know, because we can take care of that order for you. Just say, hey, is that piece from an hour and 20 minutes still available? And we'll say, sure it is. Just, definitely check it out. Follow us on Instagram, follow us on Facebook, look at all of our pretty rocks, and again, thank you guys for watching our stream, and hopefully you get to catch us next weekend. Alrighty, have a good day.